Okay, so members, today we are going to see how do we express a number in the modulus argument form, or common known as the polar form. But please don't forget to subscribe to the channel. Now, the polar form of a complex number is, if z is equal to this, we have seen how to represent a complex number on an other diagram. So the real part is there as x, the imaginary part is as y, meaning that from here up to here, this will be my modulus of z. Remember, using Pythagoras, if I use this triangle, my r squared will be this squared, from here up to here is x, then from here up to here is y squared. Getting the root will be equal to this, and I have seen that this is the modulus of a complex number. So this r is equal to the modulus of z. So where there is r, that's why I'm having it as the modulus of z. So from here, start using 3, sine is equal to the opposite here is y. Then the hypotenuse is r, and we make y the subject because we need y. Also, cos is equal to adjacent, which is x units, over hypotenuse, which is r, and we make x the subject. So I'm shooting them here is that my x from here, then my y is there, so that r is common, then moving it, we'll be having r equal to cos plus I sine theta, where r is the modulus of this complex number, and theta is the argument. Theta is the argument of that complex number z. Examples express the following in polar modulus form. We first identify the quadrant. So this one is positive and this one is also positive. Meaning, if the real is positive and the imaginary is positive, means in the first quadrant. That helps us to get the argument of that complex number. So all we need is, we always need the modulus. So from here, my modulus of this. So modulus of z here, we say we shall get the square root of, we square the little part, then plus we square the imaginary part. Our imaginary part is 3, the whole squared, and so from there we shall get 2 units. We also get the argument. We have seen that the argument of this complex number is in the first quadrant, so the arg of z, we say always it's an inverse of the imaginary over the real part, which will be tan inverse of root 3 over 1, and this will give you 60 degrees. You can convert radians by dividing through by 180, which will be 5 over 3. So now, writing it in modulus form, so my z will be always r into cos theta plus I sine theta. You have your r as, your r here is 2 into, now cos theta is the argument. Our argument is 5 over 3, then plus I sine our argument 5 over 3. So this is its argument of z, and that's how you have expressed this number in modulus argument form. When I come to this, I first ask myself which quadrant. We have a negative real, negative imaginary. So negative, negative. So it's in the third quadrant, and this is how we get the argument in the third quadrant. Meanwhile, we first get there. Its modulus will be negative 1 now, squared to the real. Then the imaginary is also negative root 3 squared. I think this will give you also a 2. Then the argument of this, the argument will say you get 180 minus the acute. So my now argument of w will be now negative into 180 minus acute. How do we get acute? Acute we now ignore the signs, it will be tan inverse of x root 3 over 1. So this will be now negative into 180 minus, this is 60 degrees, which will give us negative, this is 120 degrees, which you can convert radians by dividing through by 180, which will be negative 2 pi over 3. Now, so now my argument of w is this. I first always identify the quadrant, because if the argument is wrong, even this is going to be wrong. So from there, so now my w will be r into cos theta plus I sine theta. So putting them there, my r the modulus was 3 units into now cos, now the argument negative 2 pi over 3, then plus I sine of negative 2 pi over 3 into. But here, remember we said cos of a negative angle is the same as cos of a positive. and sine of a negative angle is the same as negative sine of a positive angle. So now simplify this, is that our W will be 2 now into cos of now 2 pi over 3. Now it becomes negative using that idea. Then because this is negative, we pull it out, so we have it now negative I sine 2 pi over 3 across the brackets. So members, that's how we have the modulus argument form, or what we call the polar form. I wish you the best. Don't forget to subscribe to the channel. You can try out this one, by the way. You try out when you have negative 1 plus I root 3. You find the modulus argument form of that number.